Hi everybody, it's Bob Giglio. So we're going to start another project, like I mentioned on my earlier video, building a cabinet for my jointer. My jointer here, 6-inch jointer. And right now, like I mentioned before, I have it on just a temporary stand with wheels on it, but it's really not something I could use. So what I want to do is build a cabinet for this, similar to what I built for the bandsaw, as you saw in my previous video. So the cabinet's going to look a lot like this. I'm going to use a 3/4 inch maple faced plywood. It's going to be a faceless cabinet design, so I get the maximum storage capacity from the drawers. And because these types of cabinets need to be mobile and they need to support a lot of weight, I use heavy duty casters here on the bottom, and I also put a center support rib in the middle of these. If you can see right here, connects the bottom of the cabinet to the top. And because I don't use a formal thick countertop on these, this rib is very important to keep the stability of the cabinet strong, and it doesn't bend and move. The other key feature with these cabinets for heavy equipment like this is on the back side, instead of doing a traditional thin backer board just to cover the back of the cabinet, what I do for these stronger cabinets is I actually use a locked miter joint here that actually is the same thickness as the cabinet sides, top and bottom. And I do that because it's all glued in. It's a very thick piece of material, and it gives me a very tremendous amount of stability from the cabinet ever racking. So this cabinet really couldn't rack because this is all glued in place. And the joints I use for this to get a very good joint, a strong joint, is a locked miter joint, which I'm going to show you the bit right here. The bit looks like this. Okay, and I use it on my router table. So let me take a close look at that bit. Okay, and the joint it produces is a miter joint, like a traditional miter joint, but it locks. So if you see it, so here's some template pieces I made, and basically, if you can see these. This is the locking portion, and this is the receiving portion, and they go together just like that. So, and what's nice about this joint, it's a nice strong joint. It's self-aligning, so when the edges meet, they always meet perfectly, and you get a lot of glue surface there. So, this is 1/2 inch material. When you use 3/4 inch material, it's a very hefty joint, and it's very strong. And the other thing is, if you're going to use a veneer plywood like this, then you see there's no interruption of veneer. The veneer goes right to the edge. So the tricky part with the joint is this edge is it's a knife's edge. So, when you sand it, a little bit the wrong way, this thin veneer can actually burn through, and you'll see some of that veneer being burnt off. So that's the only hard part about these types of joints. But as far as stability and strength and looks, they are the best that I've come across so far. So I've been using them on this cabinet for the first time, and I like them. I like them a lot. So we'll be using them on this project. Here's the same thing for 3/4 inch, very hefty. This is actually the material I'll be using for this next project. But look at how that joint meets together. And if it's done right, you get almost just about a perfect fit on that joint. It looks like this. So it looks good, and it's very strong. So I'm going to be using that type of joint here. And so we're going to start this project here. The cabinet's going to look a lot like that cabinet. The difference is dimensions. I want this, because my shop is so small, I want this joiner to be below my table saw height. So that when I'm doing large sheets of long boards, I don't want to have to move this out of the way every time I do that. If I make the cabinet short enough, and this top is below the tabletop of my table saw, it can stay here, and I can use it as a joiner, and I don't have to move it out of the way when I do big projects on my table saw. To get started, I did a drawing of the new cabinet with all the dimensions, and it's going to have, like you see here, 4 drawers, 2 smaller ones, 2 larger ones. Very simple design, and I want to draw attention to the top of this cabinet. The top of the cabinet is actually already made. So the joiner I have over here, this piece here, this skirt right here, I already built this. I used those minor joints that I talked about to build this, basically a box. I contoured it so that it meets exactly the bottom shape of the joiner, and I put a gasket here. And the reason I did that is 2 reasons. This joiner by itself came from the factory with an open bottom stand, not this stand. And the motor hangs down for the belt tension. You can see it over here. The motor hangs down below the height of the bottom of the joiner. So what happens is the motor's below, and it can't sit in a flat surface at this level. But what I do is I built this skirt here, and with that skirt, the motor's actually hanging down here, right about here. It still sits flat on a table, which is going to be our new cabinet. And then at the same time, I actually designed this for a dust port. So this will accept a conventional 2¼ inch vacuum hose for my dust collection system. And now it's all sealed, like I said, with the gasket. So when I bolt this to the new cabinet, then I'm going to have a dust collection, and I'm going to have the ability for the motor to hang down, and it won't be any problem. Once I completed the drawing, then I went ahead and I detailed out a material list with all the dimensions for the pieces of material I'll be cutting, and as well as the hardware I'll be needed. So we'll get the hardware during the time we're building this, and right now we can go ahead and start cutting the 3/4 inch plywood for the cabinet carcass itself. And then we can move on to the drawer fronts, the drawer sides, and the drawer bottoms. To minimize wastage for cutting full sheets of plywood or leftovers, whatever I may have, I go ahead and lay out a cut diagram. This is a drawing of a 4x8 sheet of plywood. And what I do is I sketch out the cuts I'm going to make so that I can minimize the wastage and make sure that I'm left with the largest piece you can see here when I'm done cutting the pieces I need out of a full sheet. I also have a leftover sheet from my last project, and this is a small dimension. You can see I did the same thing here for cutting out some of the pieces, the drawer fronts and the partition. So we're going to go ahead and start cutting now. And here is the setup I've been using. This is out in my driveway, and I use a straight edge here. Instead of lugging this sheet down to the shop, I cut them here with an 8-foot straight edge that has tracks in it, which I have this polypropylene sled here that fits into it I mounted a circular saw to it. And this slides back and forth on the sheet, and the saw will do the cutting. And what's nice about this is I can get a really good straight edge here using the guide, and then I can trim it up as I need it down the shop on my table saw. But the nice thing about this is that all the dust that I'm going to generate is outside. So that's a big benefit of doing it out here. Plus, I don't have to lug this sheet all the way down to the shop and get it on my table saw. Okay, now that we've got these pieces down to a more manageable size for the shop, we'll run them down here, and now we're going to do the final trimming on the table saw and the chop saw, again with the final dimensions. Now that the pieces are cut for the cabinet, I went ahead and laid them out on my work table. And as you can see, I got 3 pieces here. This is going to be the top piece, the back of the cabinet, and the bottom piece of the cabinet. And through all 3 of them, I drew a center line, and around that center line, I then put the lines that outline the partition, the stiffening rib that we talked about. And that stiffening rib is going to be dadoed into all 3 pieces to make this cabinet very strong. The size, the width of that dado is determined by, in using calipers, I went ahead and measured the thickness of the material of the rib that we put in there, and it comes about 728, almost 0.73 inches. So once I know that information, I go over to a nice handy table I made that I laid out the actual overall thickness of the dado based on how many chippers and how many paper shims I use. So in this case, to get to 724 right here, I would need 3 5/32 chippers, 1 3/32 chipper, and 1 paper shim, which is 1/32, which would bring me up to the 724. I then use those number of chippers here into my dado stack, and then set the height to 3/8 of an inch. And then just to make sure that everything is correct, I went over here and I cut a test piece like this with that set of dado, exactly the way it was set up. And just to make sure it fits properly, it's nice and tight, but not too tight. As you can see, that's a very nice fit. So we're going to go ahead and cut the dados of these pieces now. To set the correct width of the fence on my table saw, I went ahead and I measured the edge of the line here, which shows 14 5/8 for the edge of the rib. And then I went ahead and came over here to my table saw, and I set that to 14 5/8, which is the same dimension. So now that I have my fence set here, my height and width of my dado set, it's just a matter of just running them through the saw. I now clean up the dado with a little bit of sandpaper, just the edges. I assembled the box roughly to show how the pieces fit together and to show you how the dado goes all the way from the bottom, back, and then right up to the top. So that's where the partition rib is gonna go. Before we can do that though, we have to now do the joinery on these edges right here. So this is where we're gonna use the lock miter bit that we talked about earlier. So what's nice about the bit is that you don't have to change the dimension of the cabinet. So if you cut this, say 30 inches, then the edge of this wood is going to make it all the way to the edge of the side, and vice versa. The edge of this side is going to make it to the top. So you don't have to make any adjustments for like a rabbit. Like with a rabbit, you have to deduct the thickness of the rabbit to get the same dimension. That's what's nice about the bit, is you don't have to do that. You cut the actual size, and then when you do the joinery, the cabinet size stays the same. What I did was, when I placed the pieces together, I marked them with a T. You can barely see it here, but I don't want to make it too dark because it's the finished surface. A T or an F for the type of joint, whether I'm going to be against the table or against the router fence. So that way, the T and the Fs will always have to mate together because they're different joints. And you can see that I did that around the entire cabinet. So for the back, I put Fs on all of all 4 sides of the back. It's going to fit right into the back of the cabinet, and then the mating corner is going to be the opposite T. So I went around and I did that to the whole cabinet. So here's the bit right here set up in my router table, as you can see, and I already set the fence height, the fence distance, and the bit height by using a couple of template blocks like this. So these have been tested before with this bit to give you a very nice joint. And it's an easy way to set, it's a quick shortcut way to set it up once you get the good templates. So this particular template goes against the fence, and that will allow me to set the fence position. And then before I do that, I set the height of the bit like this so that it lines right up with the template, as you can see there. So that's how we set the bit up quickly. The other thing that we want to do is, because this bit takes off a lot of material, as you can see here, you want to do it in 2 passes. You don't want to do a single pass this, because if you do, you will end up ripping out this rib and really straining your router motor, and it's not recommended. So what I do is I take a spacer like this, and I use double-sided tape, as you can see here on both ends of it. And I use a spacer on the first pass. So all I do is I place it in, against the fence, and I stick it to the fence with the double-sided tape, just enough to hold it. And then this will become the first pass, and then the second pass, I'm going to remove it, as you'll see in the video, and then I'll do the final pass. And this is good for both the table piece as well as the fence piece, because it pads out both. One last detail before we run the panels through the router table is that I need to, when you're doing the cutting here on this edge, it becomes a very sharp knife's edge, and it becomes very delicate, and you won't be able to press it firmly against the fence to get the right gauge on the cutting depth, because it's so thin. So to get around that issue is you can use a backer piece like this, a supporting piece with double-sided tape, and I'm going to go ahead and tape that. I'm going to place it on the edge, right on the exact edge of the piece, and that will give me a nice backing piece as the joint is formed. And I'll always have a nice support here against the table or the fence. I dry fitted the cabinet pieces together, as you can see here, using some strap clamps to hold things together in place. We're looking at the cabinet's back here. I have the face of the cabinet's on the table, so it makes it easy now for me to make sure everything fits together nicely. And what's nice about these locked miter bits is that everything is locked in place, so they will even stand by itself without the straps, but I'm going to use the straps to get very close to what the glue up position will be. I'm going to remove the back of the panel, and then from the back, I'm going to do the final measurements on the partition and then slide that in from the back. I added the center rib, support rib, and now you can see it from the face up view. And as you can see, it's all ready to be glued up. All the sides are fitting together nicely. You can see the joints, how they come together. So we're gonna, first we're gonna take it all apart. I'm gonna sand each piece because it's easy to sand it when they're flat boards, as opposed to being a cabinet. In here, it's difficult to sand. So we're going to take it all apart, sand the panels, and then we're going to glue it up and assemble it. Now that we let the glue dry overnight, it's time to unclamp the piece. With the cabinet box done, it's time to now start to add the accessories to it. It's like drawers and wheels and other things to make it functional. So we're going to focus right now on the wheels of the box. And what I did was I bought these wheels online, Amazon, and the reason I bought these was because they're adjustable, and I can adjust the height of them as needed in the future once they're installed. So to use these, I'm going to use these inserts, these wood screw inserts like this, these right here. And we're going to drill a hole into the bottom of the cabinet here and to screw them in with a hex wrench. But one of the issues I'm facing here is this insert is about 1 inch deep, but the plywood frame of the box is only 3/4. So to solve that problem, I'm going to glue on some of these pads here. They're 1/2 inch veneered plywood, and we're going to glue these in the 4 spots. And then once I have that glued, I'm going to then drill a hole and thread these inserts in. So to drill the holes for the stud of the wheels, I set up a block here, which I pre-drilled on the drill press to make sure that it is exactly perpendicular to the surface of this 2x4. And I did that because if I was just to drill these through with a 1/2 inch bit, if I'm off a little bit, then the stud on the wheel is going to be misaligned. And that would be not a good thing, because I don't want my wheel doing this. I want it to be perpendicular as exact as possible. So what I did was, when you're doing hand drilling like this, you make a template or a guide block, and basically I drill this on the drill press and with the same bit, 1/2 inch bit. And now when I drill it, I'm going to hold this against the hole, and this will guide me to keep it perfectly square. With the wheel inserts installed, I flipped the cabinet over to expose the top. And now we're going to put this skirt on the top of the cabinet, like we've been talking about. And the skirt serves 2 functions. One is that it allows me to elevate the jointer off of the flat surface like we talked about earlier. Here is the jointer, and you can see it on its side. You can see how it is, it extends down, the motor frame extends down and hangs down to give the proper belt tension. And by doing that, I need to add additional height here before putting it on a flat surface. So that's the function of the skirt. The skirt also allows me to control the dust by, if you look into here, here is the joiner rotary drum and the knives, and this generates a lot of chips and dust. So what I did was I sealed this chamber off in the skirt, as I can show you here. And here is the dust chamber here, and then I added a vacuum port, as you can see here, till I can attach this, and all of the chips get sucked out of here by my dust collection system. So the skirt serves an important function. The other thing I want to draw attention to you is on my other cabinets I built, where the center rib is here, I always put a set of wheels here, so I have direct line of support, stiffening the cabinet from the roller, the bottom roller, all the way up to the top. But in this case, I don't really have to do that because this skirt here serves a structural purpose as well. Because it is such a wide piece of plywood, then it's going to transfer the load. This is acting like a beam. It's going to transfer the load to the edges here, which are closest to the corners. And therefore, I don't really need to put additional wheels here like I normally do to catch the weight, the heavy weight here coming down, because it's really being transferred out to the edges. First thing we need to do to attach the base is to locate the holes we need to drill into the top face of the cabinet. And as you see here, I had installed threaded inserts. I got 4 of them here. And now we're just going to locate these holes on the top of this cabinet and then drill them. To locate the center of the holes that I want to drill for the skirt, I screwed in some 5/16 bolts. So now once I have them in, I've elevated the skirt enough off of the base, off the top, so that I can put marks there. I now know where the bolt heads are exactly. And from that, I'm going to put a center punch to those holes and drill them. Using the 5/16 by 18 by 1.5 inch bolts, I dry fitted it and bolted it, the skirt to the cabinet, and it looks good. To finish up the box, we're going to actually do the final sanding and finish now, because it is a great time to finish all the surfaces. I like finishing the inside and outside of the cabinet, even though you don't see the inside. I like to have everything sealed. And it's a great time to let that finish dry while we are making the drawers and the drawer fronts. So the first thing I want to do is conceal these plies on the edge of the plywood. This is the only place in the cabinet where you'll see the plies of the plywood. So to take care of that, and by the way, you won't see these edges unless the drawers are open, because we're going to do a full overlay design on the drawer front. So they'll all be covered when the drawers are closed. It's just when they open, you can see them, see these edges. So just to give it a little extra finishing touch, I'm going to apply a veneer, heat-sensitive veneer that glues onto the edges, and with basically an iron, and I'm going to heat it and then roll it onto the edge, and then we're going to trim it off. So we're outside and we want to finish this now with, I'm going to use a Watco Danish oil. I kind of like this natural tint to it. So it gives a nice golden luster to the, this is a birch plywood, face plywood. So it's going to give it a nice sheen, and it's going to seal the wood, which is the most important thing I'm looking for. So I'm just going to apply it with a foam brush. Waiting 15 minutes, I then wipe off the excess of the oil, and that's it. That's why I like this finish. It's a very simple application, and now all I have to do is let it dry after I wipe it down. Give a hand-rubbed appearance.